Okay, ladies and gentlemen, let's talk a little bit more. Last time we drew tree diagrams, and the nice thing about a tree diagram is you can use it to solve problems. What we're going to do is count the number of outcomes. The outcomes are the results of a particular experiment. Let's take a spinner, but let's keep it simple. 1, 2, 3, 4. And let's take a coin. And we're going to flip that coin. It's going to be heads or tails. So in this case, we could make a tree diagram very quickly. On a spinner, you could get a 1, a 2, a 3, or a 4. And if you get a 1 on the spinner, then you can flip the coin, and you can either get a heads or a tails. You could get for 2 a heads and then a tails. If you got a 3, you still can get a heads or a tails. A heads or a tails. So now I've drawn a tree diagram of my possibilities. Now, we saw from a previous problem that your tree diagrams can get pretty crazy pretty fast. So what I want to do is I want to help you find a way to come up with a number of outcomes a bit more easily. What you need to ask yourself is, how many choices? Well, for the spinner, I had how many choices? There were 4 options. For the coin, I had heads or tails. That's 2 options, which means if I multiply those options together, I come up with 8. Well, that's what I get here. 1, 2, 3, 4, 5, 6, 7, 8. And if I'm looking for the probability of finding a particular outcome, I want a 1 with tails. We say a 1 and tails. Well, there's how many options that are a 1 and a tails? That's just 1 option out of 8. What's the probability of a 3 and a heads? 3 and heads, well, there's 1 option there. So that's going to be 1 out of 8. Now, let's do something a bit more challenging. What's the probability of an even number and heads? Well, even number, that's 2 and a heads, but 2 and a tails doesn't work. 3 and a heads doesn't work because 3 isn't even, but 4 and a heads work, so that's 2 out of 8. So that means my chances are 1/4. Now, so finding the number of options by using a tree diagram helps, because then we can find probabilities with it. But let's go to Baskin Robbins. Now, Baskin Robbins is for ice cream, and they are known for having 31 flavors. I want to make an ice cream cone, and I want to have 2 scoops. So the problem is, for cones, they have sugar, cake, and waffle. So that is 3 options for cones. And then for ice cream, they have 31 flavors. I'm not going to list them, but I do know there are 31 of them. So how many different choices can I have for an ice cream cone? Well, it's going to take 3 choices for the cone times 31 choices for the first scoop of ice cream. And as long as I'm allowed to get the same scoop for the second one, 31 scoops for the second one. I wouldn't want to draw a tree diagram for that, but I can come up with a total number of options by taking 3 times 31 times 31. And that means that if I go to Baskin Robbins for a 2-scoop ice cream cone, I can have up to 3 times 31 times 31. I can have 2,883 options. So this is called the multiplication principle. The multiplication principle because we multiply. So using that system, see what we can do with finding the number of possible outcomes.